Hello again, this is an optional tutorial where I'm going to show you how I created this little sandbox project based on the third-person example template. We are going to use this project in the next tutorials to see how we can save and load the actors from this project using this plugin so you can apply this knowledge in your own games. The link of this project will be in the description. And if you're an advanced user of Unreal Engine 4 already, please follow the next tutorials because for this video I'm not going to use any functionality of the plugin. So if I click play, you can see that there is a pickup that restores my health, and there is also a door. If I press E, I can open and close the door. I also place it in a spawner. When I press 3, I'm going to spawn 100 actors. And there is also simple AI that is patrolling, and you can see that there is a widget too where I have a score, a health and stamina. So let's see how this spawner is working. If I open it, you can see that on begin play I enabled the inputs. When I press 3, I am printing spawn actors, and then I am spawning 100 BPU cubes. And I'm making a random transform in this case. I make a transform and I'm using a random rotator and a random location based on the box collision. So if I press 3, 100 BP cubes will be spawned inside the box collision. Now let's see how this pickup is working. You can see that there is an event on component begin overlap, and I created a sphere and spotlight and a component called interrupt movement. And you can see that the behavior type is ping pong, and also it has two control points. One is 000 and the second one is 0050. Let's see how this on component begin overlap is working. I created an event overlap based on a sphere. So you can see that I'm casting to a third-person character. So this will only work with third-person characters. As you can see, as I'm using a sphere, this sphere should have the collision should be overlapping the pawn. Otherwise it will not work. After casting to a character, if it's true, I'm using a timeline to reduce the size of the sphere. So you can see the timeline has two control points. So while the timeline is running, I'm going to resize the scale from this sphere, from the initial size to the final size using the alpha. After the timeline is completed, I'm applying a negative damage to the third-person character, so as the damage is negative, in fact I am restoring the health of the character. After that, I'm applying a simple effect, and then I'm destroying the actor. So if I click play, you can see that the pickup is reducing its size and then it's been destroyed. Now let's see the door logic. Let's open the door, and you can see I created a custom event here called toggle door. I also created a boolean called isDoorClosed and set it to true, and I branch it, so when it's true I set the door closed back to false, and when it's false I set it back to true. I'm using a timeline here too, so if I open the timeline you can see that there is a simple function using two control points. And while the timeline is running, I am setting the relative location of the cube from 000 to the door final location. This door final location is a vector that is editable and is also showing the 3D widget. So if I go to the editor, you can see that I can move this door final location. So if I click play and I open the door, the door will be moved to the final location. I'm also using a box collision as the root component, so when the cube is moved, the box collision will stay in its place, so we can keep ray tracing the box collision. It is also important that this box collision can block the visibility channel, so the third person character will ray trace in the visibility channel. Now let's see how the AI is working. As you can see, I created an AI character that is in fact a copy of this third person character. And if I open it, you can see that I created a health variable, so this AI character can die if it receives damage. I created a reference to a patrol node too, that it is editable. So if I choose my AI character, you can see that I can select the desired node. This desired node will be used for the first time this AI reacts. So if I select the first patrol node and then I click play, the AI will move first to the selected patrol node. The save and load functionality are the ones we implemented before, and you can see that it also has an apply damage to third person character, that it is using the damage collision component, and when it overlaps the third person character, it's going to apply a damage of 10 to the third person character. The damage collision component of this actor, it is just an sphere component, sphere collision component, as you can see here, and it is also overlapping a pawn. It is overlapping a pawn. This AI character is capable of receiving damage too, so on event any damage, I am updating the health of this character. As you can see, if the health is greater than 100, I am setting the value to 100, and if it is less than 0, I'm setting to 0, so it never goes beyond that. So when it's less, the health is less than 0, less or equal than 0, I am set simulating physics of the mesh, so it appears that it is killed. Now let's see how the AI controller works. If I select the AI character, and I look for the AI, I'm going to write AI. You can see that it is using the BP AI controller I created. So if I open this BP AI controller, I created an event on begin play that runs the behavior tree I created, and also created a custom event called restart blackboard logic that restores the logic of the blackboard of the behavior tree and also clears the value from the blackboard. It is very important that the name of this value it is the same as the one you used in the blackboard. I also created a custom event for stopping the logic of the behavior tree. The most important event here is the run behavior tree that will run the behavior tree I created. This AI character will follow the commands from the behavior tree. So let's open this behavior tree. You can see that it is using Blackboard asset I created. This Blackboard has a self-actor key, that it is a key that is created by default. I also created a patrol node key, and it's very important to remember the name, because when you want to clear this node, this value, the name must be the same. This patrol node is the type of BP patrol node. So in the behavior tree, as you can see, I'm using a sequence that will try to get the next node in the patrol points. You can see that here, right here, there are 4 patrol nodes, and each patrol node it's pointing to the next patrol node. So in this case it is pointing to the patrol node 2, and you can see that this actor has only a next node as a reference, and it is exposed. So the patrol node 1 will point to the patrol node 2, the patrol node 2 will point to the patrol node 3, and the patrol node 3 it is pointing to the patrol node 4, and the patrol node 4 is pointing back to the patrol node 1. So in other words, the AI will follow this path. Let's continue watching the behavior tree. I created here a custom task for getting the patron node, and then I'm moving to this patron node. So let's see what this get next node is doing. You can see that this object is right there. So on begin play, this task will try to get the patron node. In this case, I created a public Blackboard key, and it's very important that the name of this key is the same as the name of the Blackboard key. So the first time this task is executing, I'm casting this key to the patrol node. So the first time this node will not exist, I am getting this this patron node from the character, from the AI character, and I'm setting this value to the Blackboard key, and then I'm finishing the execution. And the next iterations, this patron node will exist, so I'm getting the next nodes from the BP patron node actor. And then I'm finishing the execution. So using this logic, this AI will move from patron node to patron node. Now let's continue watching the third person character. I'm going to close all the windows. You can see that I created the logic for shooting on click, so when I press the left mouse button, I'm going to trace a sphere by channel using this logic for the start and end locations. I'm using also a radius of 50, and the trace channel will be visibility. So the hit actor, if it is an AI character, I'm going to apply a damage of 100. So if I hit an AI, I'm going to insta-kill it. I'm also updating the stamina. So each time I click fire, I'm going to reduce my stamina. On each tick, I am also increasing the stamina, so I will always have stamina to use. It is very important to see that the trace channel is visibility, and to have the trace channel, the visibility channel, active in the damage collision from the AI. In this case, it's in the capsule component of the AI. So if you see the capsule component, and you can see that it is blocking the visibility channel, so this AI character will receive damage. So if I test it, you can see that it is shooting on each click, and my stamina is being reduced. So if I hit the AI, I will kill it. I also have a similar functionality for opening a door. In this case, when I press E, I'm going to trace a line by channel using the visibility channel. So if I hit a door, I'm going to call the function toggle door. And it's the function, the event we visited before. So if I click play, you can see that when I press E, I am tracing a line. So if I hit the door, I'm going to open this door. This character also has the functionality for receiving damage and being killed, but in this case, this character will receive damage each time it's hit by the AI. It is very important that the damage collision can overlap each actor, so in this case, both damage collision are overlapping the pawn. Now let's see how the widget is working. In this case I created a basic widget and I am initializing this widget inside the third person game mode. In begin play I am creating a basic UI widget and I am adding it to the viewport. This is a basic UI for showing the score, the health and the stamina. And in this case, the score is a text widget, and the health and the stamina are progress bars. Let's see the bind function for the text score. You can see that it is using a my character reference that is being initialized inside the event construct of this widget. I forgot to mention that my character also has three variables created that are health, stamina and score. And you can see that the values are 50 for health, 75 for stamina, and the score is 10. So in this case I'm getting the score from the character. I am converting it to text using 4 minimum integral digits. So for binding the health, I am just obtaining the health from the character and I am dividing it by 100. I'm doing the same thing with stamina. And this is the end of this tutorial. In the next tutorial I'm going to show you how to save and load all the actors we created. For example, how to save and load the door, the AI. As you can see, the AI is being saved. What is not being saved is AI state. The transform of the AI character is being saved, but not the states of the behavior tree. Let's continue in the next videos. Thanks for watching this tutorial.